Hello everyone. In my previous video, I talked about hashing in cryptography and its characteristics. Today, I will show you some hands-on using Java as programming language. This is my development ID IntelliJ, which I am using for Java development. You might have used it, or you might be using Eclipse or NetBeans or Android Studio or any other Java development ID. So here I created a Maven project, named it hashing in cryptography. This is my main class. I will try to replicate the flow of password. You can say a login page in which user needs to enter his or her password for login. So I declared a string in which hard-coded password is assigned. So this password, in real, this password will come from the text box of login page where the user will enter the password. So here I'm using Java security package for cryptographic functionality. It is highly recommended that we should use Java native classes present in Java security package for any cryptographic related work. If you have any precise requirement which is not getting fulfilled with Java security package, then only in that case you can use other libraries like Bouncy Castle, Google's Guava, etc. if they are fulfilling the requirement. But in normal case, we should always use native Java security classes. So this message digest is the class which is having methods for generating hashes. So first we create the object of this message digest class by providing the algorithm name here. In this case, let's provide SHA1. This class is having method named digest, which will take input as a bytes and will create hashes. This hash bytes will be fixed length bytes depending upon the algorithm we choose. So as its name suggests, digest, it will take any length of input and it will digest it, and it will provide output of fixed length depending upon the algorithm name we have chosen here. In order to make it more human readable, I converted this hash bytes into hash string using method name byte array to hex string. Let me run this program now. So here you can see this is the hash uh, in hex string. Let me copy this and paste it in notepad. So you can see it is having 40 hexadecimal character. It means that it is of length 40 divided by 2, it is of length of 20 bytes, because one hexadecimal character is taking 4 bits. It means 2 hexadecimal character will take 1 byte. So total 40 hexadecimal character will take 20 bytes. 20 bytes is equal to 160 bits. So SHA1 is taking 160, SHA1 is producing 160 bits of output. Now let me just change the algorithm name, SHA256. Let me run it again. So here you can see the output. It is contain 64 characters. It means that 64 hexadecimal characters, meaning 32 bytes, which is equal to 256 bits. So SHA-256 is producing fixed length output of 256 bits. So similarly, we can change the algorithm name to MD5, etc. So this is the small code by which we can generate hash of any string. In this case, you can take example of password. This password is coming from the text box of any mobile application or any desktop application. Then we calculate the hash. Now we converted it to hex string. Then we can store this string into our database here. So now let us assume that you don't want to use Java native classes for the hashing or any cryptographic work. Let us say that you want to use bouncy castle. So what you can do is you need to add dependency for bouncy castle. If you are using Maven build system, then you can add dependency like here. And if you are using Gradle, then you can also add dependency like in the way of Gradle system. If you are creating normal Java application, then you might add jar file of bouncy castle in lib directory. So this is Maven project, so I added dependency for bouncy castle here. Now you can create like this. Just comment this line and write again here like this: message digest is equal to message digest dot get. If you see there is a overloaded methods of get instance. So here there is a method in which we can provide algorithm name and the provider name. So provider is the, you can say, the cryptographic functions provider. In our case we wanted to use bouncy castle, so let me use this overloaded method get instance. Algorithm name is SHA1 and the provider is, we can provide the class name like new bouncy castle provider. Since we have added the dependency for bouncy castle in Maven, so we can see the classes here. That's it. Now just run the program again. Here you can see the output for the SHA1. This was our output from the native Java classes, and this is the output from bouncy castle, and you can see both the outputs are same. In order to show you more, let me just debug it. I put a breakpoint here. So if you see the digest object, let me evaluate it. It has method name get provider name. So BC, it shows bouncy castle. So in this case the provider currently in use is bouncy castle. Let me close this. If I comment this line and go back to our previous way and debug this again, digest object evaluate dot get provider name. Here is the sun from Java. So you can see in our previous way the provider was sun. That is, you can say the native Java libraries will be used in this case. So normally we should always use native Java classes for the any cryptographic work. We should not use bouncy castle and other libraries. We should always stick with native Java classes, because we don't need to worry about any update or security changes. It will be happen. It will happen smoothly if we go with the uh, default Java way. So in message digest dot get instance method, there is a way to tell Java that don't use your own default provider, rather use the provider that we passed uh, in method parameter. So this is how we tell Java to use this external provider, you can say in this case bouncy castle. That's it for today's video. In next video I will talk about how this normal hash is not sufficient for this high performing computing era, where the computers are very powerful and they can brute force the this normal hash very easily to fetch the password. So I will talk about how we can put some extra security so that it will create difficulties for the attackers, for the high performing computers to brute force the hash and fetch the password. Thank you guys.